In this video, I want to define the idea of injective and surjective functions. Let's start with the idea of injective. For an injective function, each element of B is the image of no more than one element of A. Another way to say this, f of x1 equal to f of x2 implies x1 is equal to x2. When we're trying to show something is injective, this here is the definition that we are going to look at. We're going to start by assuming f of x1 is equal to f of x2 and show that we need to have x1 equal to x2. And injective functions are also known as one-to-one functions. Here's an example of an injective function. Our set A, our domain, has 1, 2, 3. B has A, B, C, D. We can see 1 goes to D, 2 goes to B, and 3 goes to A, but everything in A goes to a different element in B. So this would be injective. Here's another example. This time I have 1 going to A, 2 going to A, and 3 going to D. But this one would be not injective. In particular, I have 2 elements in A going to the same element in B, which would make this not an injective function. Next, let's look at a surjective function. We say a function is surjective if each element of my set B is the image of at least one element of A. This is the same thing as saying that B is the range of my function. Another way to say this, for all elements little b and b, there's a little a in A such that f of A is equal to B. And this is also known as onto. Here's another function, and this one is going to be onto because everything in my second set in my range does get hit. So that would be an onto function. However, if I look at this function here, this would not be onto. It is not surjective. In particular, because this element here does not get hit. We do not have an arrow coming to D. We can also talk about a bijective function. A bijective function is both injective and surjective. Let's consider the function f going from r to r, defined by f of x equal to 3x plus 4. I want to know if it's injective and is it surjective. Let's start with injective. For this, we need to assume 3x1 plus 4 is equal to 3x2 plus 4. We can subtract 4 from both sides and divide by 3, and I get x1 is equal to x2, which is exactly what I need for injective. For surjective, I'm going to start by doing some side work. I'm going to let y be equal to 3x plus 4, and I'm going to solve for x. So we can subtract 4 from both sides and divide by 3. To actually prove it's surjective, we start by saying let y be a real number. And we let it be a real number for this set, not for the domain, but for the second set, the output set. Then we're going to look at f of y minus 4 over 3, the thing we found over here to the right. This means 3 times y minus 4 over 3 plus 4. Well, that's y minus 4 plus 4, which is equal to y. So I found something to input to give me y as an output. And since y was an arbitrary element, it proves that this is surjective. Next, let's consider the function f going from r to r, defined as 2x if x is an integer and x otherwise. This time, let's start with surjective. And I'm going to claim this is not surjective. In particular, there's no x in r such that f of x is equal to 1. There's nothing that maps onto 1. The second part of this function is only considering non-integers and outputs non-integers, so it cannot output 1. And the first part of this is inputting an integer and outputting 2x, so it's outputting even integers, so it cannot output 1. So not surjective. What about injective? For this, we're going to have to consider 3 cases. Let's start with the fact that we want to consider the first part of this function. So let's suppose 2x1 is equal to 2x2. Dividing both sides by 2 gives me x1 equal to x2. If we're in the second piece of this function, we have just x1 is equal to x2. So both of these would be injective. But what if we're in one of each? So what if we have 2x1 equal to x2? Well, this case right here is impossible. How do we know? Well, here x2 would have to be a non-integer, and 2x1 is an even integer. And there's no number that is both an even integer and not an integer. So this case would be impossible. So we have to be in one of these two cases, which both worked out. So this function is not surjective, but it is injective. Now let's consider this function. This function is defined from a cross b to a, and is defined by f of xy equal to x. So we input an ordered pair, and we output the first coordinate. My first question, is this injective? And the answer is no. Let's let y1 and y2 be in my set B, with y1 not equal to y2. We can then say that f of x comma y1 is equal to x, and f of x comma y2 is equal to x. So I have two different inputs mapping to the same output, which would mean not injective. Now let's talk about surjective. Let's start by letting x be an A, so we want to pick something in this output set. Then we know that f of x comma, I'm going to write this as EB to indicate the identity element in B, is equal to x. So no matter what element you pick in A, you can find something that outputs to it. So that means this would be surjective.